Hello friends, welcome to my channel Shri Physics. Today we are going to solve some more examples from this second chapter of 11th physics, and the chapter is mathematical methods. In previous two videos we have solved some numericals, and all those numericals were based on law of parallelogram. Today's problems are based on this concept of rectangular components of a vector. We know that rectangular components of a vector are the components which are directed along positive directions of x, y and z axis. For example, in this figure, vector r starts from origin of coordinate system, three axes, x-axis, y-axis and z-axis. Then this vector r has three components, vector rx, vector ry and vector rz, directed along x, y and z axis respectively, such that vector r is equal to vector rx plus vector ry plus vector rz. Vector r is resultant of rx, ry and rz, or we can say vector r is addition or sum of rx, ry and rz. This can also be written as vector r equal to rx into I cap plus ry into j cap plus rz into k cap, where rx, ry and rz are magnitudes of rectangular components, and I cap, j cap and k cap are called as rectangular unit vectors. I cap, j cap, k cap, they are unit vectors. Their magnitude is 1 and they have specific directions. Direction of I cap is along x axis, j cap is along y axis and k cap is along z axis, and they are mutually perpendicular to each other. Magnitude of that resultant vector r in terms of rectangular components is given by this formula: r equal to under root rx square plus ry square plus rz square. If vector p and vector q are two vectors such that vector p equal to pxi plus pyj plus pzk and vector q equal to qxi plus qyj plus qzk, then their dot product vector p dot vector q is given by px qx plus py qy plus pz qz. And if two vectors are perpendicular, then their dot product is 0. Vector p dot vector q equal to 0 when vector p is perpendicular to vector q. So today's examples are based on this formulae. Let us start the examples. First example is, if vector a equal to 4i plus j plus k and vector b equal to 6i minus 2j plus 8k, find vector a plus vector b and vector a minus vector b. This is very simple example. Vector a plus vector b, we have to just add the vectors. While adding these vectors, we have to add the corresponding components. Means we have to add x component with x component of another vector, y component of first vector with y component of second vector, and z component of first vector with z component of second vector. So here we can write the same step. We have just removed the bracket. 4i plus j plus k plus 6i minus 2j plus 8k. So add the corresponding components, x component of first vector with x component of second vector, means this 4i plus this 6i. Therefore we get this 4i plus 6i equal to 10i, this j minus 2j means minus j, this k plus 8k means 9k. So this is addition of two vectors a plus b. This is answer of first part, very simple example. Then vector a minus vector b. So we have to subtract vector b from vector a. Vector a is 4i plus j plus k minus vector b, that is 6i minus 2j plus 8k. Now remove the brackets, as there is a negative sign here before the second bracket. When we remove this bracket, we solve this bracket, sign of each term will change. This 6i will becomes minus 6i, minus this minus minus becomes plus, so plus 2j, this minus plus, that becomes minus, so minus 8k. Now just add these vectors, add the corresponding components, x component of first vector with x component of second vector. So 4i minus 6i, that will be minus 2i, this j plus 2j will be 3j, this k minus 8k will be minus 7k. So this is a minus b, vector a minus b. This is answer of second part. So this was a very simple example. Now see the second example, example number 2. Find the magnitude of the following vectors. First vector is vector p equal to 3i plus 2j plus 6k. Second vector is vector r equal to I plus j plus 2k. And third vector is vector q equal to I plus 2k. Now again this is very simple example. The first vector is 3i plus 2j plus 6k. We know that vector in terms of rectangular components is given by pxi plus pyj plus pzk. I, j, k represents rectangular unit vectors. They just represents the directions. Px, py, pz are components along x, y, z axis respectively. They gives the magnitudes along x, y and z axis respectively. If we compare these two equations, this given equation with this standard equation, we get px equal to 3, py equal to 2 and pz equal to 6. Now we know formula for magnitude of vector in terms of rectangular components is given by this formula. P equal to px square under root px square plus py square plus pz square. Now just keep the values. See here, this px is 3. Compare this equation, standard equation with this given equation. Px equal to 3, py is equal to 2 and pz equal to 6. So keep px equal to 3 here, py equal to 2 and pz equal to 6. So see what we get, 3 square plus 2 square plus 6 square. We have just kept these values 3, 2, 6. Now solve this. 3 square will be 9, 2 square will be 4, 6 square will be 36, 36 plus 4 that will be 40, 40 plus 9 that will be 49. So p equal to root 49. Now take the square root, p equal to 7 unit. This is magnitude of vector p. ही p ची मॅग्निट्यूड झाली. मॅग्निट्यूड दाखवायची असेल तर त्याच्या डोक्यावर ॲरो काढायचा नाही, म्हणजे फक्त मॅग्निट्यूड झाली, यामध्ये डायरेक्शन आली नाही. जेव्हा आपण असं लिहिलं वेक्टर पी तेव्हा त्याच्यामध्ये दोन्ही पण आहेत, मॅग्निट्यूड आणि डायरेक्शन. सिमिलरली फाइंड द मॅग्निट्यूड ऑफ सेकंड वेक्टर. द गिवन वेक्टर इज I plus j plus 2k. The vector in terms of rectangular component can be written like this. Now compare these two equations. Rx equal to 1, coefficient of vector I, Ry equal to 1 and Rz equal to 2. विद्यार्थी मित्रांनो, ॲक्च्युअली युनिट व्हेक्टर दाखवताना आपण त्या व्हेक्टरच्या डोक्यावरती कॅप काढत असतो. तसं कन्व्हेन्शन आहे, तशी पद्धत आहे, परंतु या ठिकाणी चुकून व्हेक्टर झालेलं ॲरो काढलेला आहे. काही फरक पडत नाही. शेवटी एक लक्षात घ्या की हे युनिट व्हेक्टर्स आहेत, त्यांच्या मॅग्निट्यूड्स 1 आहे. तुम्ही परीक्षेमध्ये लिहिताना इथं I कॅप, J कॅप, K कॅप असं लिहा. नाव कम्पेअर दिस टू इक्वेशन्स. Rx इक्वल टू 1, Ry इक्वल टू 1, Rz इक्वल टू 2. Formula is same. Magnitude of resultant vector is given by under root Rx square plus Ry square plus Rz square. Rx is 1, Ry is 1 and Rz is 2. Keep these values. So 1 square plus 1 square plus 2 square under root. So from that we get 1 plus 1 plus 4. 2 square is 4. Add this. 4 plus 2, 6. Now use log table to find out square root. There is a page of square root in log table. See the square root, we get r equal to 2.449 unit. This is magnitude of this vector r. Similarly determine magnitude of this vector q. Given vector is I plus 2k. There is no term of vector j, means that magnitude is 0. जेव्हा याच्यामध्ये I किंवा j किंवा k चा टर्म नसेल याचा अर्थ त्या डायरेक्शनला मॅग्निट्यूड 0 असते. सो द स्टँडर्ड इक्वेशन इज Vector q can be expressed in terms of rectangular components like this: qxi plus qyj plus qzk. If we compare these two equations, qx equal to 1. Now here there is no term of j, means this qy is 0, qz is 2. Formula is same. Magnitude of resultant vector in terms of rectangular components is under root qx square plus qy square plus qz square. Now keep qx equal to 1, qy equal to 0, qz equal to 2. Substitute the values. 1 square will be 1, 0 square will be 0, 2 square will be 4. So 1 plus 0 plus 4, that is 5. Determine the square root of 5. See the square root of 5 in log table. Calculator is not allowed in exam. कॅल्क्युलेटर अलाउड नसतं परीक्षेमध्ये. त्यामुळे हे स्क्वेअर रूट कसं काढायचं हे तुम्ही शिकला पाहिजे. त्यासाठी मी यापूर्वीच एक व्हिडिओ यूट्यूबवर अपलोड केलेले आहेत. 3 व्हिडिओज मी अपलोड केलेले आहेत लॉग टेबलच्या संदर्भात. ते तिन्ही व्हिडिओ तुम्ही बघणं गरजेचं आहे. स्क्वेअर रूट ऑफ 5 इज 2.2396 and write unit because we don't know the unit of these quantities. ह्या क्वांटिटीज कोणत्या आहेत ते आपल्याला दिलेलं नाही. फोर्स आहे का, डिस्प्लेसमेंट का, व्हेलॉसिटी का, ॲक्सलरेशन. त्यामुळे आपण फक्त पुढे युनिट असं लिहितो. दिस वॉज एक्झाम्पल नंबर 2. नाव एक्झाम्पल नंबर 3. फाइंड युनिट वेक्टर अलॉंग द वेक्टर्स. Vector p equal to 3i plus 2j plus 6k. Actually a single vector is given. So we have to find unit vector along the vector. Vector p equal to 3i plus 2j plus 6k. How to solve this example? Vector p in terms of rectangular components is written like this. Given vector is 3i plus 2j plus 6k. If we compare these two, we get px equal to 3, py equal to 2 and pz equal to 6. Now to find unit vector means any vector divided by its magnitude. So given vector is 3i plus 2j plus 6k, we have to divide this vector p by its magnitude, and we know the formula to determine magnitude: under root px square plus py square plus pz square. Therefore we can write p cap. Now unit vector p cap equal to vector p upon p. Vector p means this given vector 3i plus 2j plus 6k, and p means magnitude of vector p. जेव्हा आपण p च्या डोक्यावर ॲरो काढलं नाही याचा अर्थ मॅग्निट्यूड. अँड वी नो द फॉर्म्युला फॉर मॅग्निट्यूड इज अंडर रूट px स्क्वेअर प्लस py स्क्वेअर प्लस pz स्क्वेअर, अँड गिवन वेक्टर pxi प्लस pyj प्लस pzk. नाउ px py pz दे आर नोन. 3 2 6 हे आपल्याला माहीत आहे. म्हणजे ॲक्च्युली हा वेक्टर पी जो आहे त्याच्या जागी तुम्ही हे ठेवू शकता 3i प्लस 2j प्लस 6k. सो वी गेट दिस. px इज 3, सो 3 स्क्वेअर. py इज 2, सो 2 स्क्वेअर. अँड pz इज 6, देअरफॉर 6 स्क्वेअर. नाउ सॉल्व दिस. दिस 3 स्क्वेअर इज 9, 2 स्क्वेअर इज 4 अँड 6 स्क्वेअर 36. नाउ ॲड दिस. 36 प्लस 4 that will be 40, 40 plus 9 that will be 49. And square root of 49 is 7. Now divide each term separately by 7. We get final answer 3 by 7 times I plus 2 by 7 times j plus 6 by 7 times k. This is unit vector along this vector p. म्हणजे हे p कॅप जे आपल्याला मिळालेलं आहे, हा वेक्टर जो मिळालेला आहे तो वेक्टर पीच्या दिशेला असलेला युनिट वेक्टर आहे. हा वेक्टर पी काही युनिट वेक्टर नाही, त्याची मॅग्निट्यूड 7 आली. म्हणजे ज्याची मॅग्निट्यूड 1 असते त्याला युनिट वेक्टर म्हणतात. त्यामुळे हा वेक्टर पी युनिट नाही, तर त्या दिशेला असलेला युनिट वेक्टर हा आहे. याची जर तुम्ही मॅग्निट्यूड काढली तर 1 येते. मॅग्निट्यूड काढण्यासाठी तुम्ही हाच फॉर्म्युला वापरू शकता, अंडर रूट px स्क्वेअर प्लस py स्क्वेअर प्लस pz स्क्वेअर. फक्त pxच्या ठिकाणी 3/7, py ठिकाणी 2/7 आणि pzच्या ठिकाणी 6/7 ठेवावं लागेल. तुम्ही करून बघा, पेपरवरती सोडून बघा, तुम्हाला याची मॅग्निट्यूड 1 मिळेल. दॅट इज युनिट वेक्टर. दिस वॉज एक्झाम्पल नंबर 3. देन एक्झाम्पल नंबर 4. शो दॅट द वेक्टर्स वेक्टर a इक्वल टू 2i प्लस 3j प्लस 4k अँड वेक्टर b इक्वल टू 3i plus 2j minus 3k are perpendicular to each other. So to prove that two vectors are perpendicular to each other, we will have to prove that their dot product is 0. Again, very simple example. Given vectors are vector A equal to 2i plus 3j plus 4k, this vector, first vector. Vector B equal to 3i plus 2j minus 3k, second vector. See here. Taking dot product of these vectors, we know dot product is given by vector A dot vector B equal to ax bx plus ay by plus az bz. Ax is 2 here, bx is 3, ay is 3, by is 2, az is 4, bz is minus 3. Keep these values in this equation, we get this step. Now this 2 into 3, that is 6, 3 into 2, that is 6, minus 4 into 3, that will be minus 12. So we get this step. 6 plus 6, that will be 12. 12 minus 12, that is equal to 0. So vector A dot vector B is equal to 0. Therefore, as the dot product of the vectors is 0, the given vectors are perpendicular to each other. जेव्हा दोन वेक्टरचा डॉट प्रॉडक्ट 0 येतो तेव्हा ते दोन वेक्टर्स एकमेकांना परपेंडिक्युलर असतात. म्हणजे आपण एक प्रॉपर्टी पाहिलेली आहे स्केलर प्रॉडक्टची, त्यामध्ये आपण असं शिकलो आहे की जेव्हा दोन परपेंडिक्युलर वेक्टर्सचा डॉट प्रॉडक्ट आपण घेतो तेव्हा तो 0 असतो. इथं डॉट प्रॉडक्ट ए आणि बीचा 0 आला, याचा अर्थ ते दोन वेक्टर्स एकमेकांना परपेंडिक्युलरच असतील, त्याशिवाय डॉट प्रॉडक्ट 0 येऊ शकत नाही. हे दोन्ही नॉन झिरो वेक्टर्स आहेत. नेक्स्ट एक्झाम्पल नंबर 5. शो दॅट द वेक्टर्स वेक्टर ए इक्वल टू 4i minus 2j plus k and vector b equal to 8i minus 4j plus 2k are parallel to each other. How to solve this? Given vectors are vector a is 4i minus 2j plus vector k and vector b equal to 8i minus 4j plus 2k. Comparing the corresponding components of vector a and vector b. Components means rectangular components, x, y, z components. Ax is 4, that is x component. Ay is minus 2, that is y component. Az is 1, that is z component. Bx, rectangular components of b, bx, by, bz. Bx is 8, by is minus 4 and bz is 2. When two vectors are parallel, always remember their corresponding components are in proportion. विद्यार्थी मित्रांनो, नेहमी लक्षात ठेवा की जेव्हा दोन वेक्टर्स पॅरलल असतात तेव्हा त्यांचे जे करस्पॉन्डिंग कॉम्पोनंट्स असतात, म्हणजे एक्स कॉम्पोनंट त्यांचा रेशो, वाय कॉम्पोनंट्स त्यांचा रेशो आणि झेड कॉम्पोनंट्स त्यांचा रेशो हा सारखा असतो. आपल्याला इथं तेच प्रूव्ह करायचं आहे की यांचे जे करस्पॉन्डिंग कॉम्पोनंट्स आहेत त्यांचा रेशो सारखा येतो, म्हणजे ते पॅरलल असतील. Comparing corresponding components of vector A and vector B. Comparing means taking ratios. So ax upon bx means 4 upon 8. 4 upon 8 is equal to 1 upon 2. Ratio of x component of A to x component of B. Similarly, compare y and z components. Ay upon by. See here, ay is minus 2, by is minus 4. Minus 2 upon minus 4. Minus minus get cancel, that is 1 by 2. Similarly, compare z components, az upon bz. Az is 1, bz is 2, 1 upon 2. Now see, ax upon bx, ratio of x components of two vectors is 1 by 2. Ratio of y components of given two vectors is also 1 by 2. And ratio of z components of given two vectors a and b is also 1 by 2. Therefore, ax upon bx is equal to ay upon by is equal to az upon bz, and that is equal to 1 by 2. Therefore, as components of vector a and vector b are in proportion, the vectors a and vector b are parallel to each other. Always remember, when you have to prove that given two vectors are parallel to each other, you have to prove that their corresponding components, ratio of corresponding components is always equal. Ax upon bx is equal to ay upon by is equal to az upon bz. म्हणजे एक फरक लक्षात घ्या, जेव्हा दोन वेक्टर्स एकमेकांना परपेंडिक्युलर आहेत हे प्रूव्ह करायचं असेल तेव्हा त्यांचा डॉट प्रॉडक्ट 0 दाखवा. जेव्हा दोन वेक्टर्स एकमेकांना पॅरलल आहेत हे सिद्ध करायचं असेल तेव्हा अशा पद्धतीने त्यांचे जे करस्पॉन्डिंग कॉम्पोनंट्स असतात एक्स वाय आणि झेड त्यांचा रेशो, त्यांचं जे प्रमाण आहे ते सारखं येतं हे दाखवायचं असतं. नाव नेक्स्ट एक्झाम्पल नंबर 6. What is that? Find m if the vectors vector a equal to 4i plus j plus k and vector b is equal to 2i plus 3j plus mk are perpendicular to each other. हे दोन वेक्टर्स जर एकमेकांना परपेंडिक्युलर असतील तर मग m ची किंमत किती? अगेन व्हेरी सिंपल, वी विल यूज दॅट प्रॉपर्टी ऑफ डॉट प्रॉडक्ट. व्हॉट इज दॅट प्रॉपर्टी? Dot product or scalar product of two perpendicular vectors is 0 as these given vectors are perpendicular, that is given in example. A and B are perpendicular, therefore their dot product will be 0. We will use that property to find the value of m. How to solve that example? Given vectors are, vector A is 4i plus j plus k, vector B is 2i plus 3j plus mk. As the given vectors are perpendicular to each other, their dot product is 0. Vector A dot vector B is equal to 0. But vector A dot vector B is given by the formula ax bx plus ay by plus az bz. Ax is 4, bx is 2, ay is 1, by is 3, az is 1, bz is m. Keep these values. So we get this step. 4 into 2 that will be 8, 1 into 3 that will be 3, 1 into m that will be m. Therefore this 4 into 2 8, 8 plus this 3 that will be 11, 11 plus m is equal to 0. Therefore m is equal to minus 11. So this is answer. तुम्ही जर m ची किंमत या ठिकाणी -11 ठेवली आणि नंतर दोघांचा डॉट प्रॉडक्ट घेतला तर तो डॉट प्रॉडक्ट निश्चितपणे 0 येतो. म्हणजे हे दोन वेक्टर्स एकमेकांना परपेंडिक्युलर आहेत. अँड टुडेज लास्ट एक्झाम्पल, दॅट इज एक्झाम्पल नंबर 7. फाइंड द व्हॅल्यू ऑफ m इफ द वेक्टर्स वेक्टर a इक्वल टू mi minus j plus 4k and vector b equal to 6i minus 2j plus 8k are parallel to each other. Here we have to find out the value of m, and it is given that the two vectors are parallel. When the two vectors are parallel means the ratio of their corresponding components is equal, means ratio of x component will be equal to ratio of y components will be equal to ratio of z components. Their corresponding components will be in proportion. So given vectors are, vector a is mi minus j plus 4k, vector b is 6i minus 2j plus 8k. Since vector a and vector b are parallel, parallel means they have same direction, their corresponding components must be in same proportion, means ratio of x components must be equal to ratio of y components equal to ratio of z components. That is ax upon bx is equal to ay upon by is equal to az upon bz. Now all values, we can find values of ax, bx, ay, by, az, bz from these given equations. You can see ax is m, bx is 6, ay is -1, by is -2, az is 4, bz is 8. Keep these values and solve this. Now minus get cancel 1 by 2, 4 upon 8 also 1 by 2, therefore m upon 6 equal to 1 by 2. Take cross multiplication, just multiply this half by 6, we get m equal to 6 by 2, 6 by 2 means 3, so m equal to 3. This is answer of this example. So in this way, in today's video we have solved 7 example. In next video we will solve some more examples. Thank you for watching.